You remember natural logs? Yeah, 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 yeah. Well, these two are so commonly used that people get tired of writing the bases down, so they don't. If I have log base 10, I will not write log base 10, I will simply write this. So in other words, it's another missing number that you have to memorize all on your own. Unfortunately. Yes? Another missing number you have to memorize on your own. Same thing right here, log base e. They never write log base e, instead they write ln of x. See right here? This stands for log natural, ln, log natural. I'm being serious. A guy who came up with this was French, and in French they put the thing first. They put the term and then the description. So they would say log natural. That's why it's ln of x. And so what that means for us is that if I have log of 10 to the 4th power, the answer is going to be 4. If I have log of 1 over 10 to the 6th power, the answer is going to be negative 6. When I flip it, the power becomes negative. If I have ln of e to the 4th power, the answer is going to be 4. If I have ln of 1 over e to the 7th power, the answer is going to be negative 7. Because the log and the e will cancel out. After you flip this, the power becomes negative, and then the ln and the e will cancel out. Yeah, and it just takes a little bit of a while for your mind to tick over. But at the beginning, you forget that this means 10, and you always begin, what's the base? What's the base? If I don't write the base down, then the base is 10. You see, that's exactly what I do, and then you finish the sentence, and I say, oh, yeah. And over here, this is still a logarithm. The base just happens to be the number e. Still a logarithm. The base just happens to be the number e. And you forget that, but that's all right. That's okay. Right? Right? Quite right. Quite right, Captain. You and the captain, you make it happen. No? Okay. There are 19 more properties of laws that we need to learn.
19.
Oh, my bad. 21.
21.
For? No. There are actually 3 more properties of laws that we need to learn. Remember, log of a negative number is?
0. Undefined.
Undefined. Log of 0 is?
Undefined.
Undefined. Log of 1 is?
0.
0. Log base 7 of 7 is? 1, and so forth and so on, right?
Yeah.
But there are actually other properties of logarithms. The first one is the summation property. If I have log of any base of 2 things that are being multiplied together, log base of mn, I can write this as log base a of m plus log base a of n. So if I was dividing, what do you think would happen? Dividing is the opposite of multiplication. So if I was dividing, what would happen?
Subtract.
You would subtract. That's the difference property of logs. Log base a of m divided by n is equals to log base a of m minus log base a of n. Very important to recognize and understand that these are the same properties. I always recommend you just memorize one and the other one is just the opposite. Yes, the less stuff you learn, the faster you learn it. Just one of those tricks to learning stuff. If you have 2 things that are opposite, you just remember one of them, and the other one is automatically the opposite. Yeah, y'all do that all the time, right? Those are the little tricks that help you through those hard, long nights when you curl up with those flashcards, and they keep you warm. Okay, we got the power. The power rule of log says this. If I take a log base a of a to a power r, then this is equals to r multiplied by log base a of a. Actually, it doesn't matter. It doesn't have to be a. It could be anything m. I like to think of this one as the command and conquer one. You ever play those sci-fi games? R is the power. It comes out front and destroys everything. You know, R comes down to the battlefield and like summoning a beast to the battlefield. You know, play Final Fantasy 7 or 8 or 9. A summon. On the R, you summon the R from on top of the mountain, and it comes on down and destroys stuff. You know. You only play more video games, you know. You're spending way too much time studying this English stuff. Woo. 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 And the last property of them all is the change of base. It says that if I take log base a of b, this is equal to log base x of b divided by log base x of a, where x is any base. This allows you to easily and smoothly transition from any base to any base whatsoever. Questions there? All right, wait for you to finish writing stuff down. So obviously, I can't just give you properties. I gotta give you a little bit of practice, right? So we'll look at some examples of how this works out. There are actually maybe 3 or 4 different classes of questions they like to ask for these right here. So let's look at some of those. Do that. No, that's the log on the E. Example. So this example says expand the log, write powers as factors. That's a long question, right? It says expand the log and write your powers as factors. So let's say I have log base 3 of x to the 4th power.
Is it factors or fractions?
Factors, F-A-C-T-O-R-S. Log base 4 times y to the 6th power.
That's x to the 4.
So, which of the 4 are they using? Change of base, the power, the difference, or the summation property of logarithms?
Summation.
I have 2 things that are being multiplied by each other, right? So I can write this with a plus sign and split them up. And so this becomes log base 3 of x to the 4th power plus log base 3 of y to the 6th power. Am I finished, however? It says after you expand the log, what it says to do about the powers?
Factor.
Write them as?
Factor.
So which of the 4 are they using right here? Change of base, power, difference, or the summation property? The power property. If I have something raised to a power, what can I do with the power? I can make it a factor. If you multiply, a factor means something you're multiplying by. So I can take it out front. So this is simply 4 times log base 3 of x plus 6 times log base 3 of y.
That's the end of it, or like you got to finish off?
We don't know what x and y are, so we can't simplify. If it was like, for instance, log base 3 of 81, then I can simplify that because I know log base 3 of 81 is 4. So this is just 4 times 4, 16. Right? But I don't know what x is. Okay, let's give you one to try. The log base. Give me a base. Give me a base. Give me a base. 2. Log base. Too slow. Z to the 5th power divided by the square root of m. Let's let you try that one. My son was watching Sesame Street this morning. It's not my fault. They got that thing. I'm like, clap, clap, it's the middle of the day. Clap, clap. That's stuck in my head.
Oh.
It's stuck. The middle of the day. They were talking about dogs this morning. Anyone finish? Don't wait that intro like that. Just beam people up like that. Someone asking a question?
You have to change it to the powers of the factor.
Yeah. Same instructions. The m should be square root, right? Square root m is the power. No, 1 squared is 2. Wait, what? Check your order. Check your order. Okay, guys, people, let's go ahead and get the answer to the problem. So first things first, which one of the 4 properties am I using? The difference, and so this becomes log base 2 of z to the 5th power minus log base 2 of the square root of m, right? You have to be careful. The z must come first. Numerator is positive, denominator is negative. And so this becomes log base 2 of z to the 5th minus log base 2 of m to the 1/2 power. Right? Square root is the power. They said write the powers as factors, so I had to find the power. But now I know the power, I can bring the power out front. 5 times log base 2 of z minus 1/2 times log base 2 of m. Questions there? Comments? The half, see right here, the radical went away. Remember there's a 1 right here and then there's a 2 right there. And that gives us the numerator and the denominator of the fraction. Okay. So, what happens if I have like 16 terms in there? So let's say I have log base 5 of a to the 3rd power times the square root of z divided by y to the 4th power times the 5th root of m to the 8th power. Doesn't that look like fun?
We skip that one.
Why? It's so easy. Let me give you 2 key principles right here when you have something like this. First things first, always write everything in terms of power. So the 2 radicals, they need to go, right? The 2 radicals, they need to go. Say hello, radicals. Bye, radicals. Z to the 1/2. And then I have y to the 4th, and then I have m to the 8/5. Okay, so that's the first principle right here. No more radicals. Okay, we only want kind, calm, understanding people. No radicals. Okay? Secondly, if you are in the numerator, you are positive. If you're in the denominator, you are negative. Look over here. When I have the m in the denominator, didn't it end up being a negative log?
Yeah.
Right? Both of these were in the numerator, right? This is over 1. Both of these are numerator, right? Notice both of them are positive. Yes? So this simply becomes log base 5 of a to the third power plus log base 5 of z to the 1/2 power minus log base 5 of y to the 4th minus log base 5 of m to the 8/5.
Then you gotta change this.
Yeah, that's the last step. But how many do I have? I have 1, 2, 3, 4 pieces. So how many logs do I get? 1, 2, 3, 4 logarithms. 2 of them will be positive. 2 of them will be negative. And like Mr. Bishop was saying, come out front. 3 times log base 5 of a. Again, they're all going to be log base 5, correct? Log base 5 of z minus 4 times log base 5 of y minus 8/5 log base 5 of m. Say that again? Oh. Questions? The good news is they have the reverse question. See how it says expand? They can also ask you to write as a single logarithm. And so all they want you to do is work backwards. Write as a single logarithm, just work backwards. So I have 1, 2, 3, 4 logarithms. So I have 1, 2, 3, 4 terms. 2 of them are positive. So I have 2 in the numerator. 2 of them are negative. So I have 2 in the denominator. And then the fractional powers become radicals. Yes? Okay, so that's our last problem of the day. Go ahead and combine as a single log. Combine all of these into one log. Make it one big log. So combine. Give me a base, give me a base, give me a base.
32.
12. 12 is the winner. Log base 12, let's put a 3 in front right here, of a minus 2 times log base 12 of b plus 1/4 log base 12 of c minus 2/5 of log base 12 of d. A, B, C, D.
What's actually log these two?
Log base 2, all of them are base 12. Log base 12 of, I can reread it. Log base 12 of 2 minus 2 log base 12 of b plus 1/4 times log base 12 of c minus 2/5 log base 12 of d. They have to be the same base or none of the properties hold. You have to use a change of base formula at that point. Yes? Yes? Which one you give me go back over? They got 4 of them.
It's 3 log base 12
Of 8.
Is the b an exponent?
No, remember that the b is the, remember a logarithm always has 2 pieces, the name and the base. This is just the number you're plugging in, called the argument of the log. That's just the number you're plugging in. We just don't know what that number is. Okay, we're almost out of time. We finished. It should take you longer to write the problem than to write the answer. Can you just write the answer in one go, right?
That's 12a?
Base 12 of A. Unfortunately, I am out of time. It's going to be log base 12, correct?
Yeah.
How many of these things are negative?
2.
So I have how many in the denominator?
2.
How many are positive?
2.
So I have 2 of them in the numerator, yes?
Yeah.
A right here is being raised to the 3rd power. B right here is being raised to the 2nd power. C right here is being raised to the 1/4 power. And D right here is being raised to the 2/5 power. See what I did right there? See what I did right there? Of course, we don't leave powers, we write them as radicals. And so this is log base 12 of a to the third power, then the fourth root of c to the first power divided by b squared times the fifth root of d squared. Like I said, it's probably not a question of difficulty, it's a question of time. You just need to sit down and practice, practice, practice. Any questions there? Comments, queries, concerns? Then you all have a nice day.